right, Ozarka again. This time we're going to be going over quadratic equations in this video. So this right here is what we're going to be primarily focused on: solving quadratics with factoring, solving quadratics with square roots, and solving quadratics with quadratic formula. A quadratic equation in the variable x is an equation in the form of this thing right here. So if you can write any equation in this form, sometimes it doesn't start in that form, you have to kind of reconfigure it to look like that. But if you can make it look like that in any way where a is not 0, b and c can be whatever you want, it is considered a quadratic equation. This is an example of a polynomial equation. In fact, it is a second degree polynomial equation. You've probably heard of polynomials before. We're going to go further deep dive later on in the class on what a polynomial equation is. It's second degree because the highest power is a 2. Okay, and that's why a can't be 0, because if a was 0, this wouldn't be here, and then it wouldn't be second degree anymore, because if a was 0, it'd be 0 times x squared, and then there's no more x squared if it's times 0. Anyway, so there's 3 common approaches for solving quadratic equations. So we talked about these already, but factoring, square roots, and quadratic formulas. So this video is basically going to be going over all of those solving techniques in that order as well. So we can solve these quadratic formulas, these quadratic equations. All right, this right here, it says, using factoring, solve quadratic equations. Basically what you're going to do is called zero product property. If you have 2 numbers, let's just say they're a and b, if they are times each other, they're multiplying each other, a times b, and it's equal to 0, then one of these has to be true. Either a is 0 or b is 0. And that's the main idea with factoring, is if you have 2 factors you're multiplying by each other, at least one of them has to be 0. Okay, so either a is 0 or b is 0, and that's essentially what we're going to be doing with these problems. We're going to basically be turning them into factors, or they might already just start as factors, and we're going to be finding a, finding b, and then solving them equal to 0, and then finding the answer to that. So it's called zero product property. We're going to be utilizing it a lot right now. All right, here we go. Examples. Solve for x. Okay, in a way, you can look at this as a, this whole thing right here, and then you can look at this whole thing right here as b. So you can set a equal to 0, which is just 2x plus 1 equals 0. And you could set b equals 0, x minus 5 is equal to 0. Now you might be thinking, whoa, this is not a quadratic formula. It actually is if you expanded it out. Okay, it is even if you don't expand it out, but you can actually see it in that format if you did expand it out. You would have 2x squared, I'm just going to do it really quick, minus 9x minus 5. Okay, so if you expanded this part out right here, it would look like this, and then obviously equal to 0. But we're not going to worry about that so much right now. I just kind of wanted to show you that if it doesn't look like quadratic, but it actually is, because if you multiplied it out, you'd end up with a quadratic. Anyway, let's go back to zero product property. We're going to solve both of these equations. We're going to subtract 1 on both sides over here. We're going to divide both sides by 2, and you have the first answer is x equals negative 1/2. Do the same thing over here. Add 5 to both sides. You end up with x equals 5. So the answers are x equals negative 1/2 or x equals 5. And I say or because they can't both, x can't be equal to 2 values at once. You can't say x equals 5 equals negative 1/2. It's either x equals negative 1/2 or x equals 5. You do have to put both of them down as the solution though, because either of them could make that original equation, this original equation right here, true essentially. So that's the first one. The next one here, same kind of thing, only there's multiple factors, but zero product property still applies. It just applies for every single factor. So we have a factor here, here, and here. So we're going to set each of those equal to 0. They're pretty easy to solve, so if you don't want to write all this work down that I'm doing, that's completely fine for my class. Some teachers want you to write everything down though. That's completely fine, but I'm just a little different. These are kind of easier. So divide both sides by 3, you have x equals 0. Add both sides to 1, you get x equals 1. Subtract 3 from both sides, you get x equals negative 3. And then add 9 to both sides, you get 9. So if you threw any of those values in right there into the original, you would get 0. Because if any single one of those factors is equal to 0, the whole thing is going to be equal to 0. It is important to note that in this case, this whole thing right here is not quadratic. Okay, that's just some other polynomial. It looks like it's 4th degree. Because there's 4 x's in there. If you multiply that out, you'd have an x to the 4th. But the same thing that we're talking about still applies because it's just already factored. even though it's not a quadratic. We're going to go over that in more detail later on in the polynomials unit, so it'll make more sense there. But for now, again, just zero product property, set each factor to 0, and solve. All right, this next one, it says solve for x by factoring. So this one is not factored already. So that means you have to factor it yourself. And since we have to factor it, I'm going to kind of show you my way that I recommend you factoring things. If you have your own way, though, completely use it. I'm going to show you a way that works for any problem, no matter what. Sometimes teachers will show you ones that work for specific problems, and then you have to kind of keep track. Does it work for this one, or does it work for this one? I like showing one that works for all of them. That way it's less things to remember, and it just yields a better grade. But if you're one of those people that can juggle multiple ways of factoring, then do it. However you want to do it, that's how you can do it. All right, so first thing what I do for these every single time is I find out what AC is, okay? A, in this case, is 1, and then C is this -3. So in fact, what I'm actually going to do is I'm going to write all that down. So A is equal to 1, because it's in front of right here. B is equal to -2. That's right here. And C is equal to -3. That's right here. Okay, and again, it is important to note, like, you might want to try to factor this on your own first before, I go over it. And I would do that for all the problems. Try to solve them first, and then watch the video and see how I do it. You learn more from the mistake, so make the mistake. Anyway, the reason why A, B, and C are equal to these values is back to what we talked about before with standard form of a quadratic formula. It looks like this. So you can just kind of match up. A is whatever's with the x squared, B is whatever's with the x, and C is whatever's by itself at the end. Okay, so we're factoring this. It's not factored right now. It's in standard form. So the next thing we're going to do is I'm going to multiply A times C. So A times C is equal to -3, and then I'm going to write the B value right below it. So there is a relationship between A times C and B that you are going to utilize to factor quadratic equations that actually factor. So that's essentially what we're going to do. Multiply A times C, because we're going to need that. We're going to find out what B is. And what we're going to do next is figure out two numbers that multiply to AC and add to B. Okay? So you'd have to think of two numbers that multiply to AC. So that multiply to -1. Well, that's 1 and -3 and -1 and +3. So now you need to think of these numbers, of these two sets of numbers here, if you add them together, which ones would actually get you -2? And hopefully you realize it's this right here. If I multiply these, I get -3. If I add them, I get -2. So I'm actually going to write that over here just for fun. -3 times 1, -3 plus 1. Now, if you cannot find numbers such that A times C, whatever you multiply to that number, and then B, the two numbers don't add for the B, then it probably doesn't factor, unless you didn't actually find the numbers correctly. But if you find the numbers correctly and you couldn't actually figure out any numbers that make that statement true that I was talking about just a second ago, then it won't factor. But anyway, we're going to utilize these two numbers now. We're going to rewrite the original by splitting the middle term. So I'm going to write x squared, and then instead of saying -2x, I'm going to write -3x plus 1x, because I'm using these values right here, the green values. I'm using the -3 and +1, because -3 plus 1 is still equal to that -2, so the equation is still true based on how it's written here. So the blue matches up with the original equation. From here, the next step is to factor by grouping. So we're going to group the first two, group the second two. Factor that first set by pulling an x out, so x minus 3, plus, here there's nothing that factors, so I'm just going to pull out a 1, and it's going to say x minus 3 here is equal to 0. So you have something like this. The main goal you want to see on this is these twins, these x minus 3's. Okay, there's an x minus 3 here and an x minus 3 here. So what you can do is actually just factor out that x minus 3 completely, and you're left with the x plus 1 equals 0. Okay, so there's an x minus 3, it's right here. There is an x plus 1 here, and that goes right there. So now hopefully you see that I have a factored equation that I can solve, and that's what I'm going to do. What you do to solve this, again, you set one factor equal to 0, you set the other factor equal to 0, and you solve. Add 3 to both sides, and you get x equals 3. Subtract 1 to both sides, you get x equals -1, and those are the two answers for this problem. All right, we're going to do the same thing with the next one, so hopefully you get these steps. Step 1 is always find AC and find B. So multiply A times C. In this case, AC is going to be equal to -2. And then find the B value, that's equal to +1. From here, we're going to find two numbers that multiply to -2 and add to 1. The way I always think of it as kind of a memory thing is like it's A times C. So I always think of two numbers that multiply to get -2 and add to get +1. So those values would be, let's see here, -1 times 2, that's -2, and then -1 plus 2, that's +1. So now what we can do is rewrite the original equation to be v squared plus -1v plus 2v minus 2 is equal to 0. So again, I want you to see the corollary here between these two numbers and how these are split right here from that middle term there. And I do try to color code all the steps, so hopefully this makes more sense with the colors. So step 1, find AC, find B. Step 2, find two numbers that multiply to AC, and those same two numbers have to add for B. Split the middle term like we just did. And next, factor by grouping. Greatest common factor here is V, so it's going to be V minus 1, plus factor out a 2 here, you get V minus 1 again, is equal to 0. Now, it is really important to understand that every single time you find these two numbers here, you should see twins here. Okay, if you do not see twins, then you did something wrong. Okay. It's also important to understand that I could have mixed up the order of this -1v and this 2v, and you still would get the same answer. I could have done, v squared plus 2v plus -v minus 2, and you would still get the same answer. So the order does not matter. You can still just do the same steps. You'll get the same answer at the end, I promise. So these twins now, you could factor out the one of the v. You could factor out a v minus 1 here times v plus 2, set it equal to 0. Solve each of these. You should have v equals 1 or v equals -2 as the final answers. Now it is important to understand what we're actually doing here. If you used this value and plugged it into this equation, so 1 squared plus 1 minus 2, you do get 0. So that one checks out. Plug in -2, you get 4, minus 2 is 2, 2 minus 2 is 0. This one checks out. So basically those two values can be used to find the two answers from the original equation. All right, number 5. This one gets a little tricky because A is not 1 in this case. Same with number 6, it's A is not equal to 1. So you're really going to want to follow those steps that I kind of drew out just a second ago. First thing that you want to do on these is it has to be in the form of ax squared plus bx plus c equals 0. So this needs to be equal to 0. So I'm going to add 13u to both sides, and now it's magically set equal to 0. Now we can figure out the AC. In this case, the AC number is -30. The B value is 13. Okay, now you need to think of two numbers that multiply to get -30 and add to get 13. And those two numbers would be 15 times -2 and 15 plus -2. Okay, we're going to use those to split that middle term. So now it's 5u squared plus 15u plus -2u minus 6 equals 0. Factor by grouping. We're going to factor out a 5u, and you get u plus 3. Plus, always factor out a negative if you can. If you can factor out a negative, do it. It's always going to make your life easier. Just want to throw that out there. So I factored out a -2. I could have factored out a +2, but it's always better to do the negative. It's easier to see the answer. Factor out a u plus 3 here. You have 5u minus 2 equals 0. All right, and once you have those factors, you should get u is equal to -3 and 2/5 as the two answers. All right, the next one, solve for w by factoring. Okay, again, it has to be set equal to 0, so what I'm going to do is add 3 on both sides and rewrite this equation really quick. So it's going to be 4w squared plus 7w plus 3 is equal to 0. Okay, from here we're going to find our AC, which is equal to 12. The B is equal to 7. Okay, this one's fairly easy. 3 times 4 is 12. 3 plus 4 is 7. That makes it nice. So now we're going to have 4w squared plus 3w plus 4w plus 3 equals. Okay, factor by grouping, and you're going to factor out a w here, and it's going to be 4w plus 3 plus, factor out a 1 here, 4w plus 3. There's those twins that we want. The 4w plus 3 is in both spots here. So 4w plus 3 times w plus 1 is equal to 0. Okay, now from here, you can solve. You should have negative 3/4 and negative 1. So w is equal to negative 3/4, or or w is equal to negative 1 for the answer there. All right, next we're going to be using square roots to solve quadratic equations. These tend to be a lot easier than what we were just doing. You don't have to do as much work for factoring. And essentially what you're basically going to be doing is just isolating the x squared and then taking the square root of both sides for this. It is important to note this right here. If x squared is equal to a, then the answer is x is equal to the square root of a or negative square root of a. Because when you square a positive, it can be positive or negative, and you'll get the same answer because a negative times a negative is a positive. It'll make more sense as we do some of these problems. So let's look at this first one here. Okay, first thing I'm going to do is isolate the x squared. If you notice, there's not really much we can do other than that here, so we're just going to subtract 3 on both sides to isolate that x squared. Now that the x squared is isolated, we can do a square root each side, but I always tell my students square root it and caboot it. You always have to have that plus or minus. I'm going to explain why in just a second, but your answer should be plus or minus 3 because it's plus or minus the square root of 9. Now the reason why you want the plus or minus is because if you think about it in the original equation, if you did 3 squared plus 3, that's 9 plus 3, that's 12. But at the same time, if you did negative 3 squared plus 3, that's still 9 plus 3, which is equal to 12. So you need to do both the positive and negative version whenever you do a square root. Okay, whenever you do a square root. Now you don't want to do it when it's like, a cube root or something like that, when it's an odd index for whatever the root is. But in this case, it's the square root. It's the second index for it. But if you did the 4th root or the 6th root or the 8th root, anything that's an even index, you're going to want to do the plus or minus each time because of what I just said. A negative times a negative is a positive. So the square is already isolated, so I'm just going to square root both sides. Now remember, square root it, caboot it. You always want that plus or minus. Do not forget about that. That's an easy thing to forget about. And you end up with plus or minus 7 because the square root of 49 is 7. I'm going to add 6 on both sides. So now you're going to get plus or minus 7 plus 6. Now what this means is it means positive 7 plus 6 and negative 7 plus 6. So that means it's going to be 7 plus 6 is 13. Another possible answer would also be negative 1. So w is equal to 13 or negative 1. And again, you can check your work by plugging it into the original equation up here and see if you actually get 49, which you would. Okay, next one, same kind of thing. We're going to square root both sides right away because it's already squared. The square is isolated. There is no plus or minus 0 with this, so you don't actually need to really worry about the square root of 0. The square root of 0 is 0 still, so that cancels. Now it's just a linear equation, similar to that first week stuff that we did. Minus 3 on both sides. Divide both sides by 2, and you get negative 3 over 2. Now, if you notice, this one does not have 2 answers, and that's just because that's 0. Plus or minus 0 is still 0, so it doesn't actually yield 2 different events for that. All right, next is completing the square, which is kind of a roundabout way of solving. I personally do not like solving it this way. It's not one of my favorites, but I like teaching it, so that's cool. But when I was a student, I did not like necessarily solving this way. Essentially, what we're going to be doing is we're going to be transferring standard form, or any other form of quadratic, into this vertex form, it's called, or the completed square form, this right here. So we're going to be converting this standard form into this form over here. Or if it's not standard form, it could be factored form or something. Either way, we're going to be converting it into this other form over here, which is vertex form, it's called. And then we're going to be solving once we have vertex form. So we're going to convert it to this and then solve from there. That's essentially what we're going to be doing. It says right here, with practice, completing the square is usually pretty straightforward. Emphasis on the with practice. You kind of have to memorize this methodology of solving. Me personally, again, I don't really like it this way because I feel like there's faster, better ways of doing this, but it's one of the standards I have to teach, and unfortunately you have to learn it. So anyway, let's get going on this. All right, so for this first one, it says complete the square. So again, we want it in vertex form, which as a reminder looks something like this. It's a times x minus h quantity squared plus k. So we want this to look like this. Okay, I'm going to kind of show you the steps that you're going to need for this. First thing that you're going to want to do is take whatever's here, divide it by 2 and square it. So take the b term, divide it by 2 and square it. So it's 2 over 2 is 1, squared is 1. And then whatever value you get, you're going to add that to what we have. So 2 divided by 2 squared is 1, so we're going to add a 1 here. And I'm actually going to use a different color, so this is easier to kind of see. Now, if you just add a 1 artificially, you also have to subtract a 1 to make it so this whole thing is still equal to what you started with. So I added a 1 artificially, I'm going to subtract a 1 as well artificially, so nothing actually changes with the value. It'll make sense as we go here. Now from here, what you just divided by 2 and squared with that b, this whole part right here, that's actually a perfect square that you can factor. And what is this factor to? Well, the easiest way to factor this, like the shortcut, is just take whatever this is and divide it by 2, which is 1, and that's basically what you use. X plus 1, quantity squared. The minus 1 still drops down here. Now if you notice, this whole thing here looks like this here. So now those actually match. And that's the new answer for that. So that's completing the square. Okay. Now we didn't solve on this because it's just an expression, but 11 and 12 are equations, so we'll actually be solving those. All right, number 11. Same kind of a thing with completing the square, only this time we're actually going to solve. So we need to get it into that vertex form that I was talking about just a second ago. First thing that I'm going to do is I'm going to subtract off the 3 on the other side, just kind of don't want to babysit it right now. So now you're going to have x squared plus 4x and then minus 3 on both sides. So 0 minus 3 is negative 3. From here, I'm going to divide this b term by 2 and square it. So 4 divided by 2 is 2, square it is 4. Now, since I added 4 artificially on the left, I'm going to also add it on the right. So now everything is still equal. It's still completely balanced. If you add 4 to one side and not the other, you will get the wrong answer every time. Okay, I'm going to factor this here. It's x plus 2 quantity squared is equal to 1. And now if you notice, we completed the square on the left. It's that x plus 2 quantity squared. It's a perfect square. It's just squared like that. And now we can solve this. Square is isolated, so I'm going to square root it, caboot it, and you're going to end up with, this cancels, x plus 2 is equal to plus or minus the square root of 1. That's just plus or minus 1. We're going to subtract 2 on both sides, so then it's plus or minus 1 minus 2. From here, x is going to be equal to negative 1 or negative 3, and that's the 2 answers. Okay, the next one we're going to do the exact same thing, but we have to reconfigure this one a little bit first. So first thing I'm going to do is subtract 6x on both sides, and then I'm going to subtract 13 on both sides. So now it looks similar to what we did with number 11. Okay, I'm going to divide that middle term by 2 and square it. So this is going to be a plus 9. I'm going to artificially add 9 on both sides. Factor this, it's x minus 3. Again, all you have to do is divide that middle term by 2 to get that perfect square. And then that's equal to negative 4. All right, now from here, we have the square part isolated, so I'm going to square root both sides. Remember, square root it and caboot it. All right, this is going to cancel, and you're left with x minus 3 is equal to, we have the square root of a negative. If you remember from the previous video, if you ever have the square root of a negative, that's an imaginary number, and you can pull an I out. So you're going to pull the I out, so it's going to be plus or minus I times the square root of 4. The square root of 4 is just equal to 2, so I'm going to write plus or minus 2I. Okay, we want to solve for x, so I'm going to add 3 to both sides, and you're going to get 3 plus or minus 2I as the final answer for this problem. So this is kind of nice because it's tying together the previous video. If you haven't seen it, it's on complex numbers, imaginary numbers. It actually is tying that together because now we have a complex solution here that has an imaginary number part, unlike the other problems that we did before that did not have that. All right, the next one is about quadratic formula. To me, this is the ideal route that you want to go because quadratic formula works with solving any quadratic formula, period. You don't have to worry about factoring it or completing the square roots, or anything like that. Quadratic formula is the way to go because it works on all of them. The quadratic formula is written right here. You're going to want to memorize this for this class because you are going to need this formula. But basically, if you have a quadratic equation in standard form, ax squared plus bx plus c equals 0, then you can actually just use this formula right here by plugging in the b's and the a's and the c's into that formula, and you'll actually get the answers for those. This thing that's underneath the square root is called a discriminant. So if you ever hear about the term discriminant, that's what that is, that b squared minus 4a. And essentially what that means is it tells us something about the solutions of the equations. If it's equal to 0, then there's only going to be one solution. If it's greater than 0, then there can be two real number solutions. If it's less than 0, then there's two complex number solutions. So that's actually kind of important to understand. If you don't actually know anything about the discriminant and you just try to solve it, you know, the way that you're going to use quadratic formula, you would get those same kind of answers either way, but it's just kind of a little shortcut. You can kind of see whatever's under that square root. If it's 0 under that square root, then there's one solution. If it's positive, then there's two real solutions. If it's negative, then you're going to have complex solutions with an imaginary number part to it. All right, so here we go. Examples, solve for x. Okay, so first thing I'm going to do is write out my a, which is 3, my b, which is -8, and my c, which is 1. Then I'm going to use quadratic formula. It's kind of a one-stop shop. Negative b, so it's going to be negative b, which is just positive 8, plus or minus the square root of b squared, which is 64, minus 4ac, that's 12. So you end up with something like this, 64 minus 12. And then we're dividing this all by 2a, which is just 6. From here, 64 minus 12 is 52, so I'm going to kind of put a 52 under there. It's a square root of 52. So it's going to be 8 plus or minus. Now we have to simplify that square root of 52, which ends up just being 2 root 13 if you simplify it. I'm not going to waste the video going over that, but you can kind of do that yourself and see that you get that same value. You can divide the top and the bottom, all of the terms by 2, so you would end up with 4 plus or minus root 13 all over 3 as the final answer. And again, it is important to note that all I did was just use quadratic formula on this. So again, make sure you write that down and use it, memorize it. You are going to need it for this class. Okay, also important to note, make sure it's always in standard form when you use it. A lot of these already have equal to 0, but still, if they don't, you're going to have to reconfigure that. All right, the next one, quadratic formula, solving for x. So it's going to be x is equal to negative b, which is -1, plus or minus the square root of b squared, which is 1, minus 4ac, which is going to be 4 times 4 times -4, which is -64. Put that there like that, and then divide all this by 2a, which is 8. Okay, this is going to be root 65. And that does not actually simplify as a square root. So you're going to get -1 plus or minus the square root of 65 all over 8. And that's the final answer. All right, on to the next one. Okay, same kind of thing, quadratic formula. So we're going to have x is equal to negative b, so it's -3, plus or minus the square root of b squared is 9, minus 4ac, which is 4 times 3 times 7, which is going to be 84. Okay, right away you should see that you have a square root of a negative here, so we're going to have complex solutions with an imaginary number part. We're dividing by 6 here. So 9 minus 84 is going to be -75, so this is going to be equal to -3 plus or minus the square root of -75, all divided by 6. Okay, I can pull that I out. I can make this positive, pull the I out like that. The square root of 75 is going to break down, since there's a perfect square of 25 in there. It's going to break down to the following. It should be 5i root 3. And then we're dividing this by 6. Okay, nothing simplifies from here, so this is the final answer. Okay, the next one, number 16. Use the discriminant to determine the nature of the solutions, which will actually tell us, you know, if there's imaginary parts to them, or if there's just one of them, or if there's two real ones. So the discriminant, again, is just that b squared minus 4ac, which in this case, it's going to be 49 minus 4 times -4 times -1. Positive right there is going to be, or negative is going to be the positive here, 49. So either way, doesn't matter what the number is, it's going to be positive, because 49 minus 16 is positive. So that means you're going to have two real solutions. All right, and last but not least, the ball is thrown from a height of 67 meters with an initial downward velocity of 5 meters per second. The height of the ball in meters after t seconds is given by the equation h equals 67 minus 5t minus 4.9 t squared. When does the ball hit the ground? So we have to translate this. So when does the ball hit the ground? We have to translate this from English basically to math. And when the ball hits the ground, that means the h is 0. So to solve this, that's what we're going to do, is we're just going to set the h equal to 0. So we're going to solve all of that basically using quadratic formula, and then it says round your answer to the nearest hundredth. The other one also said to write your answer to the nearest thousandth for number 14, but I didn't actually do that. I guess I could do that really quick right now just to be thorough. And you should get 0.88 for the plus version of it. If you did the minus version of it, you would get negative 1.13. All right, onward we go. Okay, so we have another quadratic formula here. I mean, honestly, what I would do is just throw this right into the quadratic formula to solve it. So it's going to be x is equal to, let's see here, 5 plus or minus the square root of 25 minus 4 times a, which is negative 4.9, times c. And then divide all of that by 2 times negative 4.9. So if you throw that in your calculator and round, you will get 3.22 or negative 4.24. The problem with this is you can't actually have a negative x value. And I shouldn't have even written x to begin with, because really this is supposed to be a t, because these are t's. So that actually illustrates my point further though. You can't have a time that's negative. So the final answer should be 3.22 seconds. So that's a video on solving quadratic equations by using factoring, square roots, quadratic formula. Hopefully that gives you an idea of how to solve quadratic equations. If you have any questions about anything in this video, let me know.